Question 2 is a very open, unstructured question looking at an experiment to determine the enthalpy of a reaction. So this question is about the determination of enthalpy changes. A student carries out an experiment to find the enthalpy change of reaction for the reaction. It gives us the equation. In the experiment, 3.18 grams of sodium carbonate are added to 50 grams of 2 molar HCl. The HCl is in excess. The temperature of the reaction mixture increases by 5.5 degrees. We are asked to calculate the energy of reaction, the enthalpy of reaction, delta HR, and we are also asked to give our answer to 3 significant figures, so it's important that we do that. And then a final piece of information is that the specific heat capacity of the reaction mixture is 4.18 joules per gram per Kelvin. So key information in this question, well obviously there's the equation. We're going to need to use that. We're told how much sodium carbonate there is in terms of its mass, and we're given the mass of and the concentration of the HCl, and we're also told that the HCl is in excess, and we're told that the temperature of the reaction mixture increases by 5.5 degrees, and we're given the specific heat capacity of the reaction mixture. So in terms of how we're going to approach this question, and these come up fairly often, what we're going to do is we're going to use an equation that we might have come across in several times, which is Q equals mc delta theta, to tell us how much energy is released by the reaction to cause the reaction mixture to increase by that 5.5 degrees Celsius. And we're then going to work out how many moles of reagents we've got to divide the energy by the number of moles to get the energy in terms of kilojoules per mole, which is what the enthalpy of reaction actually is. So if you haven't done this question yet, now would be a good time to pause the video and have a go, otherwise we will carry on. So let's have a look at what we've got here. The temperature change is delta theta. That's a positive number, so the temperature has increased. We have two masses, so I'm going to call this one M1, that's the mass of the sodium carbonate, this one M2, which is the mass of the HCl. We've also got a concentration of the HCl as well. We're going to be using our equation Q equals mc delta theta. First question is, which mass are we going to use, because we've got two masses, and people often get this wrong, but it's really important to realize that the mass that we're going to be using has to relate to the temperature rise. So the question to ask is, what exactly is increasing in temperature, and then what is the mass of that? So what's increasing in temperature here is the whole reaction mixture, which is our 50 grams of HCl plus our 3.18 grams of sodium carbonate. So the mass we're going to use in this equation is the total of those two masses added together. So our Q is equal to 53.18 times C, which is 4.18, times our temperature rise, which is 5.5, and that works out as 2.6 joules. Units are joules because the units of C are in joules per gram per Kelvin. My mass was in grams, my temperature rise was in Kelvin, so units are all fine. Now, delta HR is for 1 mole of sodium carbonate, as in the equation here. So the enthalpy of this reaction is for 1 mole of sodium carbonate reacting with 2 moles of HCl to make 2 moles of sodium chloride, 1 mole of carbon dioxide, and 1 mole of water. We're told that the HCl is in excess. That means that the sodium carbonate is limiting. So all of the sodium carbonate will react. It's the limiting reaction. So our moles of sodium carbonate equals the mass over the MR. Work out the MR, which is equal to sodium, which is 23.0, so we've got two of those, plus 12 for the carbon, plus 3 times 16, and that works out as 106. So our moles of sodium carbonate equals 3.18 divided by 106, and that is equal to 0.0300. So our delta HR is equal to the energy that's been released, which is our 122.6, divided by the number of moles of sodium carbonate, and that is equal to 40,753 joules per mole. But the question has asked for the answer in kilojoules per mole, and if we didn't spot it there, we should spot it here. So divide that by 1000 equals 40.753 kilojoules per mole. A couple of things to do before we come up with our final answer. Firstly, let's remember it wants it to 3 significant figures, so that is equal to 40.8 kilojoules per mole to 3 significant figures. And then the last thing, which is really easy to forget, is to remember that our temperature increased. Therefore, this is an exothermic reaction, and exothermic reactions have negative enthalpies, so our final answer is going to be minus 40.8 kilojoules per mole.